All right, hello again, everybody. Welcome back to Airbus 320 Tech Talk. What do all those buttons do? Welcome back to today's episode. I'm talking to you from Philadelphia on an overnight here, and really appreciate you joining me again. So let's jump in and start our discussion for today. Picking up last time where we left off, we were on the overhead panel working our way down from the fire section here. So the one we're going to talk about today is this hydraulic section of this panel right here. So first off, a little bit about the hydraulic system in general. Why do we have this in the first place? Well, if you consider the aircraft, or the modern aircraft anyways, it's a very large machine, and just like a forklift or a digger or a front loader or some sort of other commercial equipment that's needing to lift very heavy loads and do a lot of work that's maybe outside the capabilities of what human muscle can do, at least anyways, the airplane is the exact same way. I mean, we've got all sorts of large flight control surfaces and landing gear that need to be raised and lowered, and all kinds of different things that need to happen in the airplane that if it were up to just the physical force that a human could provide, it really wouldn't be possible to do what we do with these modern aircraft. So that's kind of probably the biggest reason why you have a hydraulic system on an airplane to begin with. And the other way I kind of think about this hydraulic system too is it's also in a way like an unlimitedly or an unlimited means of bending and piping various control capabilities through the inner workings of the airplane. I mean, imagine if you had to snake wires and pulleys and cables and all this kind of stuff through all these bends and turns of the structure of the airplane that you would need to route from where the control input is made in the cockpit maybe out to the surface. There's a lot that goes into that, but if you consider the hydraulic system once again, I mean, it's just a routing of piping and passing pressurized fluid through this routing of piping accomplishes certain things. So along those lines and with that notion, I mean, you could almost fashion this piping in an unlimited amount of ways and do whatever you got to do to route it around the structure of the composition of the airplane in general. So that's kind of just one extra little thing that I think of when I consider this hydraulic system here. So and of course to show you a graphic, the next logical question might be, well, what exactly does this hydraulic system service? So we have a graphic straight out of the flight crew operations manual. And we're not going to go down the list and just list every single one of these here. But you can kind of pause the video and take a look. But I mean, you can just kind of see, each of the individual components that's kind of fed off each of the three systems that we have: the green system, the yellow system, and the blue system. And kind of this concept here also that to consider as you look at this graphic is just this fact that this hydraulic system being one of the most important systems on the airplane, it needs to be redundant because we're so reliant on this system specifically to fly the airplane. And one very interesting fact about the Airbus, unlike a lot of the other airplanes I've flown or other aircraft out there still to this day, you need some form of hydraulic pressure from one of these systems to fly the thing. So just kind of an interesting fact there to tell you about. But like we said, just this idea that if one system were to fail, the others kind of back them up, and you're able to still accomplish everything you need to accomplish to fly the airplane, land it safely, and get on the ground, or where you can rectify the problem that you have. Another thing to point out too is that you could kind of think of the green and the yellow systems are kind of our biggest, our main systems in the airplane, and kind of doing most of the work. And the blue system just kind of is there standing by and kind of providing a backup to what these other guys are doing, and just kind of giving us in this instance, kind of a bare minimum amount of equipment if we were only down to this backup system, once again, to still kind of fly the airplane, of course, in a degraded, from a system standpoint fashion, but still adequate enough to get the airplane on the ground and end the day safely, so to speak. So just a little bit about the components that are fed off of each system once again. But coming back to the panel here, the next thing we'll talk about is what all these buttons do and how do we use them in our day-to-day. And right off the bat, most of these buttons on the panel here, they never get touched in the day-to-day operation. The only one that we manipulate on a regular basis is this the yellow electric pump switch here, and we only use this when we're single engine taxiing. So we'll kind of, as we step through this, talk a little bit about why that is. But just to move from the left to the right, starting with the green system here, we have this engine 1 pump switch. So this is the engine-driven pump switch here itself. And normally the engine-driven hydraulic pump just comes on when the engine is started. So therefore, this switch always remains in the in or the automatic position. We never touch it. And the only thing this would do is if you pushed it, it would turn that pump off for whatever reason if you were directed to do so by an ECAM. And that is the purpose of that button there. The one on the yellow side works exactly in the same manner. The engine 2 pump here, same exact concept, does the same exact thing. So pretty simple, straightforward there. We already kind of hit on it, but the yellow electric pump, it's just an on and off switch that we can turn that yellow electric pump on when we need to. The RAT manual on switch is a guarded switch, and once again, you'll remember from other discussions, anytime we're touching a guarded switch in the cockpit, we need to have concurrence and verification from our flying partner there. So if for some reason you needed to deploy the RAT for a loss of blue system hydraulic pressure, you could do it manually here. And one other thing to point out while we're at the switch and talking about it, the automatic deployment of the RAT in the sense of the hydraulic case or the loss of blue hydraulic pressure, it does not happen automatically. Now that contrasts to the situation where we're talking about electrics. If both AC bus 1 and AC bus 2 lose power while you're flying, the RAT will automatically deploy and the emergency generator will start, and you'll get electric power back onto the airplane. But the kind of a different concept where, once again, it would take some sort of pilot intervention to reach up and manipulate the switch if you just had a blue system hydraulic pressure failure anyways, that you would actually have to take this action to deploy the RAT and get yourself hydraulic pressure back into that system. The next switch, also a guarded switch, always stays in the auto position. We never touch it in our normal day-to-day, but it's just the electric pump switch. And the blue hydraulic electric pump just comes on whenever after any of the engines are started. And one other thing I wanted to mention about the electric blue pump switch here is, if you remember back to our discussion where we talked a little bit about the maintenance panel. So on the overhead there was actually a switch for the blue hydraulic electric motor. This one, it kind of differs from that, because unlike the switch on the top panel there, that was actually an on-off switch that if you needed to run the blue hydraulic system for some reason with the engine shut down, you could use that switch to do so. But here, once again, this switch differs in the sense that this is actually an off switch that, for whatever reason we needed to turn it on and take it out of the auto, or excuse me, take it off and turn it out of the auto mode there. We would do that with this switch here. The next button here is the PTU switch. Once again, it never gets touched, it always just stays in the automatic position. And first of all, what is this PTU? It stands for Power Transfer Unit, and basically it's a way to use the opposing side's hydraulic pressure to provide pressure to the other side. So let's say we have the number 1 engine started, so we have the green system pressurized, and if we weren't to use this yellow electric pump to pressurize the yellow system, because once again we're assuming the engine 2 is off this point, the PTU would automatically operate, and it does this anytime it sees a difference of 500 psi between the green system and yellow system hydraulic pressures, which, by the way, normally operate at 3,000 psi plus or minus 200 pounds per square inch is what the book says. So this PTU is kind of a way to use that hydraulic energy once again to provide hydraulic power and access to all these other systems that reside on the yellow side, or vice versa. You can kind of look at the little arrows here, and the flow of power really is what this means. So you could, like I said, use either system to power the other side's components that reside on it. And one important thing to talk about when you consider this PTU here is it's very important to understand that none of these hydraulic systems really trade fluid, so to speak. So there's no transfer of fluid at any point in the system. They all are completely separate, reside on their own. So don't get confused with this PTU here. You're not actually transferring fluid from one side to the other. It's just you're transferring power in the sense from one side of the system to the other. So hopefully that makes sense. And one other interesting thing to point out about this PTU, if you've been on an Airbus and you've kind of wondered what that really weird, annoying, kind of groaning dog sound sounds like occasionally here or there, you'll hear at various points, when the plane is taxiing around, really. That's the PTU activating, and that's kind of what its job is there to do. So, like I said, hopefully that makes sense to you guys. And just to kind of tie it all up, I just want to point out also, if you were to pay close attention to, just these green lines here, it does kind of tell us a lot about the system in general. So, this little kind of curved area here means the blue system is completely independent on its own, does not interact in either way, shape, or form with the green or the yellow electric or hydraulic system. Excuse me. Green and yellow do kind of have this interconnected nature in a way through the PTU, but you can kind of follow the arrows and see really where the power flow, if you will, or the hydraulic power potential is able to flow through. And it kind of makes sense if you look at this little this icon right here, or the indication right here. You just have an arrow, but you have this little stop line here that means you couldn't use engine 2 hydraulic pressure, I guess, to run the electric pump. I mean, there'd be no reason to do that. But just kind of the significance of the graphics there. It's kind of way more than we really think about in our day to day. Because like I said, the only thing we really do is reach up and use this electric pump switch here when we're single engine taxiing. So. That is just some high-level stuff about the panel and the buttons themselves. The next thing we could do is we'll bring up a lights test, and I want to just kind of talk about some of the fault lights here and what they mean. So we already kind of discussed what these off lights mean. Obviously, that would be if you once again reached up, manually manipulated the switch, turned the system off, or took it out of the auto mode. If there was some reason to do that. But just to hit these one by one, so the first one we'll talk about the fault light in the PTU switch here. What exactly does that mean? That could mean either an over temp in the hydraulic fluid reservoir, low air pressure in the hydraulic reservoir, and to kind of add on a little bit on top, we actually use engine bleed air to maintain some sort of head pressure into the hydraulic reservoir that kind of keeps that fluid constantly under pressure. And the reason that we do this is you don't want to have the pumps ever be in a situation where they call it cavitating, or it's really kind of hiccuping. So if there was some interruption of fluid, this would be bad for the system. We kind of get air in the lines, and it's just it would cause problems for us. So when we talk about this air pressure in the reservoir, that's exactly what it means. It's the head pressure on the hydraulic fluid itself. And just a little side tidbit, factoid, the normal way the system operates is it gets its bleed air from the number one engine for all three of the systems, rather, but it is capable of being fed from the other sides, but way deeper than we need to talk about today. But so we had the over temp in the reservoir, so the fluid's getting hot, low air pressure in the reservoir, or a low hydraulic quantity in the reservoir. Those are the things that would trigger the fault light in the PTU push button switch there. The next one in the engine pump push button here, the fault light would come on if the pump was providing low pressure, so it wasn't pumping enough. The system decided that it was normally supposed to be doing. Also an over temp in the reservoir, also low air pressure in the reservoir, and also low quantity in the reservoir. So once again, these two switches, same conditions to bring that fault light on. And the last one, the blue electric pump switch and also the yellow electric pump switches, these fault lights would come on if you had a pump low pressure, an over temp in the reservoir, low air pressure in the reservoir, low quantity in the reservoir, and also if the actual pump was overheating. So though that's a kind of a breakdown of the fault lights there specifically. And I pulled a few other graphics just because there's kind of some extra just interesting things I wanted to kind of share with you about the hydraulic system. I took a few snapshots just to kind of show you, it's kind of what we're looking at, when we're once again in our day-to-day. So this is a snapshot of the hydraulic synoptic page, and we're just sitting at the gate, so everything is depowered. So just kind of wanted to break down a little bit about what we're looking at here. First of all, we have, obviously the indications for the green system, the blue system, and the yellow system. These markers down here are just they're quantity indicators. So we kind of have the arrow that kind of points at where the actual quantity is at this given point of time. We have the normal range that's kind of indicated by this little green little rectangle here. You have the advisory range here by this white band, and then you have the low quantity range here is indicated by the this amber color here. These are the hydraulic shutoff valve switches, or the indications rather. And if you back up, the last episode we talked about the fire push button panel there, and we had a means to close these valves. This is actually what would close if you were to use that fire push button up top there. But normally they stay open if everything's operating as it's supposed to, and there's no problems in the system. But you have the engine-driven pump here, and right now the engines are shut down, so of course we have a low pressure indication there, and therefore we have no pressure or a 0 psi reading in both of these sides here. This of course is just the blue electric pump here, and it's just the dash there. It just means that it's off. This just shows where the rat could feed in and provide hydraulic pressure to the system if we needed it to. And of course the electric hydraulic pump here, kind of the same graphic, just showing us that it could feed in there and feed this yellow hydraulic system if we needed it to. And of course we have the PTU here that once again it kind of mimics the graphic that we saw in the overhead panel, where it just kind of tells us that, hey, hydraulic power or potential could flow either way through the system. There's no interconnection between the blue system or the green and the yellow system. And right now the PTU is it's doing nothing. So it's just these arrows are kind of open here, and it just kind of it looks as it does. So to contrast that, let's say, or let's take a snapshot of what it looks like when we're flying. So this is normal indication that we'd see when we're up in the air, for example. So everything's on. We have normal pressures. Everything's green. PTU is not running. One really interesting thing that I wanted to point out about the green system here is it's always been kind of a curiosity of mine as to why they designed this graphic the way they do, but this is actually a normal indication. The green quantity here, resting a little bit below this green normal range here, and like I said, I have no idea why they did this. I would love to talk to an Airbus engineer to pick their brains about this one, but this is a normal indication. This is what we see every day. Once the landing gear has been retracted and we're off and cruising around just normal like every day. And the reason is because the landing gear being such a big system, there's actually a certain amount of fluid that kind of works its way into these hydraulic actuators and things that just kind of resides in those areas during the cruise portion of the flight. So when the gear is up, and therefore you just have this different quantity reading that's registered by the airplane. It's kind of seen in the reservoir, and that is the reason why it looks that way. So just some kind of high level stuff there. One other thing I wanted to show you guys also was a graphic. Once again, this is just kind of while we're flying, and this is the flight control page of the system synoptics there. And it just it gives us a little bit more detail also about what systems are being fed by what hydraulic system. So you can see here that the speed brakes and the slats are fed by the green, blue, and the yellow system. The left aileron is fed by the blue and green, the right aileron by the green and blue, etc., etc. Sorry, these got a little washed out just because of the angle that I was taking the picture, but you kind of get the same idea. I mean, all three systems feed the rudder. Pitch trim is fed by green and yellow. Left elevator by blue and green. Right elevator by the blue and yellow. And it just kind of backs up and it drives home that point that just kind of says, hey, the whole reason why this is designed the way it is because of redundancy. We need to have a way to keep flying the airplane if we were to lose one of these hydraulic systems. Totally, take it out of the loop because there was a leak or there was a break or something catastrophic happened. We still need to have a way to manipulate the flight controls, of course. This is very important for us to get the plane safely on the ground. So, like I said, just kind of a little add-on to kind of give you some detail about what that looks like and what we're looking at in our normal flying scenario kind of thing. And one other thing, just to back up, if you were curious about that little PTU graphic, just, this is straight out of the manuals. These are the different indications that we would see, depending on what the system was doing at a given point in time. So, for example, here, the PTU isn't doing anything. So there's no indication, there's no fill, and these what normally would be green. That's another kind of pet peeve I have, that the Airbus tech pub folks have a lot of these just gray and white graphics in the manuals. It would be nice if they kind of color coded them. It would just kind of make things a little bit easier to read or decipher, but anyways, you get the idea. And then we have the two contrasting scenarios here, where here the yellow system is driving the PTU, which is in turn driving pressure, driving pressure into the green system. Vice versa here, the green system is providing pressure to the yellow system and allowing us to operate all our components as needed for whatever given situation the plane is operating at the point in time. So that kind of wraps up everything that I wanted to tell you guys about the hydraulic panel and the system there. As always, if you have questions, please leave them down in the comment section below, or be happy to field them for you and do my best to answer them as best I can. So in that notion, last video I had another viewer write in. So first of all, Abby Thomas, or Abai, I hope I'm saying your name right. Apologize if I'm not. But first of all, thank you again for your interest in the channel. I really appreciate you tuning in. And that's kind of one of the funnest things for me, is to get engagement from people on the channel here, because it's just fun. It's fun sharing this data with you guys. So anyways, to cut to the chase, Abby's question he had, and this is a very good question, very observant. I'm impressed you asked this, but he asked, does the fire light behind the engine cutoff lever display anything else other than fire? Is it a push button or just a light to warn you about the fire? So in the last video, we kind of talked about this section here. We were talking about the overhead once again. There was the fire panel that we had, but there was kind of a connection in systems. So right now we're looking down on the center pedestal, just below the thrust levers here. This is the engine starting panel here, and we kind of talked about, we did a lights test last time. We talked about this fire indication here and why that was there. But when we did that test, the fault light didn't come on, and so he just kind of saw like this kind of half, blank space here. And being the smart guy that you are, Abby, like I said, very observant. There was some space here that there is another light behind here, and it is for something completely different. So first of all, two parts to the question. This fault light has nothing to do with the fire scenario in the airplane. This is actually for when we're starting the engine. If there was a start a failure or an abnormality rather with the engine start itself. So if we had a hot start, a hung start, maybe no light off, the engine actually registers this as a fault. There's a lot of automatic things that happen. It's pretty neat starting at the engine on the Airbus. They made it so simple for you, but the plane will actually do certain things on your behalf when it registers this fault. So that's just what the light is there for, to tell you have a fault when engine 1 or 2 is starting. And then there will of course be some indications on the ECAM as well, but kind of the same idea. Like I had mentioned last time, is they just kind of put this light down here to kind of get your attention and say, hey, this is the engine that's having the problem. Idiot, really, because that's the way I think about these things. They try to make them foolproof, but just to lead you right down the right path and not manipulate the other engine switch when you got a problem on the 1 or 2 side, depending on what the scenario is. And second part of his question, he had asked about, is this a push button or just a light? It is actually just a light. So if you were to push your finger onto this thing, it wouldn't move anywhere. It doesn't do anything. So just there to serve as an indication. And the second question that he had, once again, another really good one. He asked about by disengaging the IDG, in other words, when pushing the fire push buttons, does it mean there results in the same action as pressing the guarded IDG disengage push button switch on the overhead panel? Once again, a really good question. So when you push the fire push button switch there, it does do a different function. It actually just deactivates or depowers the IDG or stops it from generating power, essentially. And this is actually a physically different thing that's happening, as opposed to the scenario when we were using the IDG disconnect switch, the guarded one up on the top of the overhead here. Let's see. Yeah, so like we said, a different action than when you were to use, or if you were to use these IDG disconnect switches here. So when you do this, there is actually a physical moving of parts that it occurs like kind of inside the accessory area of the engine where the IDG is residing. So Once again, I'm not a mechanic. I've never worked in these things. I haven't built one. So I don't know if it's actually like a shaft that slides out, or a gear that disengages, or like a clutch that opens up. But there is some physical break in the system that allows for the IDG to completely like come off of whatever was spinning it before, or allowing it to make power, and it just completely takes it out of the system. So once again, a really interesting thing and big thing to understand about the system is, once again, when you use this IDG push button switch here to disengage the IDG as opposed to deactivate the IDG. This is something you can only do once in flight. You couldn't engage the IDG, and this is a maintenance action that would have to come in and occur after the plane's already landed, and it's on the ground, and the mechanics come in and do their thing. So hopefully that answers your question, Abby. Like I said, to everybody out there else who's watching, appreciate it if you subscribe, hit the like button if you like what you see. I'm always trying to find ways to make these a little bit more interesting and engaging for you guys. So also looking for feedback too. But thank you again, and until the next time, have a great day.